Hi everyone, it's Sorkin. Today we have a problem when we are given a node in a network and we need to find, for example, in this case, the node is 2 and we need to find the minimum distance for a signal to travel from that node to all other nodes in the network. So for example, in this case, right, the signal to travel from 2 to 1 is 1, from 2 to 3 is 1, and from 2 to 4 is 2, so we are returning 2 as a minimum time for a signal to travel to all nodes. Which algorithm we can use in this case? We should use one of the shortest path algorithm. In our case, we are going to use Bellman-Ford algorithm. So in Bellman-Ford algorithm, what we are going to do, we are going to create an array of integer. We are going to maintain the distance from our node from 2 to all other nodes. So for the distance from 2 to 2 is 0, right? And the time to travel from 2 to 2 is 0. And to all other nodes, in our case, it's infinity. So let's set them to infinity, to 1, 3, and the 4, it's infinity. And what we do in the algorithm, so what the way it's implemented, that we are going over our edges. In our case, it's times, right? It's our times is our edges. We are going over times n minus number of times. So n is being the v minus number of times. So in our case, it's n minus number of times, so number of nodes, right? So we go, and every time we are updating the value of our nodes if they are less than the previous value. So for example, in this case, let's just go over it only once. So to travel, so let's go over times once. So the first one is 2, the distance go from 2 to 1 is 1, so right, so 1 is 0 plus the value of 2 is 0, 2 plus 1 is 1, 1 is less than infinity, so we are updating this value. The same here, so to travel from 2 to 3 is 2, the time for 2 is 0, 2 plus 1 is 1, 0 plus 1 is 1, and the 1 is less than infinity, so we are updating this value. How about 3? The last one is 3, right? To go from 3 to 4, it takes 1. So for 3 to 4, in our case, time to travel to 3 is 1. We have it. 3 plus 1 gives us 2, is less than infinity, so we are updating also this value. After we have all these values, what we do, we go over this array and define the maximum value, because that value is the minimum time. So the minimum time that will be required to travel to all nodes. So it takes only 1 to travel to 1, 1 to travel to 3, and takes 2 to travel to 4, and the all nodes, in our case, we are returning the max value, which is 2 in our case. Okay, first thing that we do here, we are creating a time to travel array of integer where we are going to store the time to travel from our node to all other nodes, and we are filling them with the infinity values. So in our case, it's integer max value, and also for the starting node, right, from the node that we need to find out time to travel to all other nodes, we are setting that to 0. For example, in our case, from 2, for 2 it's going to be 0. The time takes to travel from 2 to 2 is 0. Then we are implementing here our Bellman-Ford algorithm. So we are running over our edges, so our times in our case, right, n minus n is a number of the nodes, n minus number of times. So at each step, what we do, we are taking our source, we are taking our destination, and we are taking our time. So we are comparing if our source plus time, if the time that takes from our source to travel to destination, if it's less than the time that is already in destination, in that case, we are updating the time to travel in the destination. So for example, let's say that we are traveling from 2 to 4, and the time that is 0 plus 2, and in the destination in 4, it's, let's say, infinity, right? We are updating that value. And at the end, what we do, we are going over our time to travel array of integer, and we are finding a maximum time, because this is the time that is required, because this is the minimum time that is required for us to reach all the nodes. So at the end, we are comparing if our max time is equals to integer max value. What it means? It means that there are nodes that we haven't reached yet. So in that case, we are going to return -1 because it's impossible to reach all the nodes. Otherwise, we are returning the max time. Okay, what's the time and space complexity of this solution? The time complexity is, as we have seen earlier, it's a number of number of edges multiplied, so times in our case, right, multiplied by v minus 1, so in our case just v, or n, doesn't matter. And the space complexity, we are using only one data structure here, array of integer, and the space complexity in this case is of v, so number of vertices or number of nodes. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.